Good evening and welcome to the last lesson of Chapter 10. In tonight's lesson, we're talking about scale factors in solids. So you're going to be able to find the dimensions of similar solids. And you're also going to be able to find the surface area and volumes of those similar solids without having to use all the different formulas for area and surface area. So it's pretty neat how we're going to learn that tonight. So we're going to go ahead and get started with the first part, talking about similar solids. When we talk about similar solids, it's still those three-dimensional figures we've been talking about. So those cylinders, those spheres, those prisms, those cones. But here they have the same shape. So the two figures are the same shape, but they're not necessarily the same size. And you'll see how I put together the similar solids here. I have a smaller and larger cone, a larger and smaller sphere, same for a larger and smaller cylinder, and so on. But then my cube and pyramid here don't have similar solids. So those two are kind of left out. But we can use them. When we have similar solids, we can use the scale factor, or the ratio of the length in one solid to the corresponding length in the similar solid. So you'll notice that we end up with ratios, and we can use those ratios, or factors, to find a missing number. So, for example, here, I could look and say, well, this pyramid has a length of 12 centimeters. And on the other one, the one that corresponds to it is x. So that is that ratio, 12 over x. I could also do the same here and say, well, the height of this one is 8. Well, corresponding to it is the one of 4. Now, what we're going to have to do is find that missing variable of x. And you'll notice I have two ratios. When you have two ratios, you can make a proportion. So 12 times 4 is 48, and that equals 8 times x. So you solve for x, and you get 6 centimeters. So our answer here is 6 centimeters. Alright, so that's the way you do it. And again, I'm going to tell you, you want to make sure you start with the same each time. You'll notice I did 12 over x, then I did 8 over 4. So whatever solid you start with, make sure you start with it for the other ratio as well. Because what ends up happening is what I'll show you here. Let's say I did my 12 over x, but instead of doing 8 over 4, I went to the other pyramid and did 4 over 8. And then I tried to solve. Well, let's see. 12 times 8 is 96, and that equals 4 times x. So you go ahead and divide 96 by 4, and you get, well, x is 24. You'll notice right away that isn't right. That is not at all right. So you need to make sure you start with the same solid each time. So now it's your turn. The two triangular pyramids are similar to find the value of x. I would like you to do this one, and when you're all done, come back and check your answer. So go ahead and pause me now. All right, let's get started, shall we? So you should have had 6 and x, so 6 over x is the same as 20 over 30. And then you would solve using the cross products. 6 times 30 is 180, and then, well, that equals 20 times x. And then you solve for x, you get 9 inches. So for this one, you should have had 9 inches. Alright, so that's the first half of your lesson. Now, this is a new part, which I think is pretty neat, actually, once you get used to it. So how to find the surface area and volume of similar solids. Now, to find the surface area, whatever that scale factor is, or that ratio from the small to the big one, you're going to square it. So you end up squaring the ratio. Then you set up a proportion. For volume, you end up cubing, or taking to the third power, that ratio. And then, again, you set up a proportion. So here in this example, I'll show you how it works. The surface area of a cylindrical vase is about 1,470 inches squared. And its volume is about 490 inches cubed. The vase is similar to a drinking glass. The diameter of the vase is 6 inches, and that of the drinking glass is 3 inches. Find the surface area and volume of the drinking glass. Well, on this one, they tell us the surface area, they tell us the volume, they tell us they're similar, they tell us all sorts of information. What we need to first start with, though, is finding that ratio. So we're going to ignore what the volume is, and we're going to ignore what the surface area is. We know we're comparing a vase and a drinking glass. And I'm going to try to draw it. It's not going to be very pretty, but I'm going to draw it. Here's my drinking glass, all right? And then here, I know my vase is going to be bigger. All right, and then it goes down sort of like that. There we go. So that's my vase. Now they tell us some information that's very important. The diameter of the vase is 6 inches, and the diameter of the drinking glass is 3 inches. This is where we get our ratio, all right? Because we compare length to length, just like we were doing on the other ones. So the diameter of the glass is 3 inches. The diameter of the vase is 6 inches, and that simplifies to 1/2. So the ratio here from the glass to drinking glass is 1/2. So now we're going to go ahead and find the surface area using this. All right, and what we do first is take that ratio of 1/2, and just like it says here, square it. So 1 squared is 1, 2 squared is 4. So that's one of the ratios for our proportion. We set it up, 1/4. So it's the drinking glass is 1/4 of the surface area of that vase, which is 1,470 inches squared. So now we set up a proportion to solve. So 1 times 1,470 is obviously 1,470. Divided by 4 is 367 5/10 inches squared. So that is the surface area of the glass. All right, so now we can go ahead and do the volume the same way. So we again start with that ratio of 1/2. But this time we don't square it, we go up back to the top and they tell us to cube it or do the third power. So 1 cubed is 1, 2 cubed is 8. So 2 times 2 times 2 is 8. That's our first ratio, 1/8. And then they tell us, well, the volume is 490 inches cubed. So again, we set up a proportion and do cross products. 1 times 490 is 490 divided by 8, and we get the volume is 61 25/100 inches cubed. That is our answer this time. All right, so now you get to try it. And here's what it says. A box has a surface area of 54 inches squared and a volume of 27 inches cubed. The edge lengths of the box are about 1/3 of the edge lengths of a larger box. Find the surface area and volume of the larger box. Now in this one, they actually make it a little bit easier because they give you the ratio, 1/3. So again, when you do the surface area, you have to start with that ratio of 1/3, but square it. And when you do volume, you start with that 1/3, but you cube it. All right, and then from here, this time they tell you to find it of the larger box. All right, so be careful when you set up your proportion, because if they want a larger box, that larger number is going to be on bottom. So you're going to have to find your x in the denominator. Go ahead though, try to set it up, and when you're all done, come back and check your answer. So go ahead and pause me now. All right, let's get started, shall we? So our ratio here is 1/9 for the surface area. Now we have the surface area of this box is 54 inches squared. Now, we know we have the surface area of the smaller box because they tell us we have to find a larger box. So this time that 54 inches goes on top, and we have to find what the bigger box is. So you go ahead and set up your proportion, 9 times 54, divide by 1, and you get 486 inches squared. That would be the surface area of a larger box. Same with volume now. 1/3 cubed, well, we get 1, and then 3 cubed is 27. Same idea, 1/27 is our first ratio, and then our volume of that smaller box is 27 inches cubed. So we need to find the volume of the larger box. So we have 27 times 27, and again divide it by 1, and you get 729 inches cubed. That would be the surface area and volume of that larger box. All right, that is your lesson for tonight. Tonight we talked about how to find similar sides of similar solids, And also, find the volume and surface area of those similar solids. You have a terrific night. I will see you tomorrow.